Hey guys, I'm Matt, a developer from Ohio. In this video, I'll demonstrate how the depth-first graph search algorithm works. Let's get started. If you need an overview of graph searching in general, check out our short related video, Introduction to Graph Search Algorithms. In this video, we'll be looking more in depth at this specific algorithm. Note that in addition to the graph, we have a search stack at the bottom right and a visited set at the top right. Keep an eye on these as we move forward. We're going to start at vertex 1. Usually you'll have a target value, but for this exercise we're going to traverse the entire graph until we run out of vertices. When we visit 1, we add it to the visited set to indicate that we've checked 1 and don't need to do it again. We'll also add each visited vertex to the search stack. The vertex at the top of the stack is what we'll call the current vertex. Recall that a depth-first search does not exhaust all possible connections before moving on, unlike a breadth-first search. 1 is the current vertex, so we'll need to visit either 2 or 3. We'll visit 2 first. In this example, we'll be choosing the minimum value when given a choice, but that won't always be the case. It could just as well be completely random. When we visit 2, we add it to the visited set and to the search stack. Now that 2 is at the top of the stack, it's our new current vertex, which means that our next vertex will be one that is connected to 2. Note that the algorithm knows not to visit 1 again, because 1 is already in the visited set. So we'll go to the next lowest value that we can reach from here. We'll visit 4 and add it to the stack. This makes 4 the current vertex. The smallest and only vertex that we can reach from here is 9. We'll visit 9 and add it to the stack. This makes 9 the current vertex, so our only way forward is from 9 to 7. We'll visit 7 and add it to the stack. But there's no way forward from 7. Remember that we can't revisit vertices. The whole objective here is to visit each one exactly once. When we get into a position with no unvisited neighbors, we can pop the current vertex off of the stack. This is basically acknowledging that we're done with this vertex and its neighbors. When we remove 7, 9 becomes the current vertex because it's at the top of the stack. There are no unvisited neighbors from here either. We'll pop 9 off the stack because we're done with it. Once the stack is completely empty, we'll know that we're done with every vertex. At that point, the search will be complete. 4 is at the top once 9 is gone. Again, it has no unvisited neighbors, so we'll pop it off. Now we're back to 2. This vertex does have an unvisited neighbor, so we should visit it. We'll add 8 to the visited set and to the stack. This makes 8 the new current vertex. There are no unvisited neighbors of 8, so we'll pop it off. And we'll pop 2 as well. We've made it all the way back to 1, but we're not done because there are unvisited neighbors. We'll visit 3 and add it to the stack. And the smallest unvisited neighbor of 3 is 5, so we'll visit that vertex. No unvisited neighbors are available from here, so we'll pop 5, which makes 3 the current vertex again, which makes 6 the next unvisited neighbor. You might think that we're done here, because every vertex on this graph is explored. However, that's only clear to our human eyes. From the algorithm's perspective, we can't be sure that there are no more vertices until the stack is completely empty. Imagine if there was a vertex 10, connected only to 1. The algorithm won't know for sure whether there is or isn't until it gets back to 1 and checks, so we'll continue the process. We'll pop 6, then 3, and finally 1. Now the stack is completely empty, and the algorithm knows for sure that every possible vertex has been visited. In this video, we showed how the depth-first graph search algorithm works. In summary, we visit one neighbor of the vertex at the top of the stack, add every visited vertex to the stack, remove a vertex from the stack if it has no unvisited neighbors, and then repeat. The important distinction to remember is that depth first moves forward every time it visits a new vertex, whereas breadth first exhausts every connection before moving forward. I'm Matt for Codecademy. Happy coding!